Hello everyone, welcome to another educational video. In the last video, we saw introduced about the solid principles in Java programming. Solid is, as we discussed in the last video, it is an acronym that represents a set of five design principles for writing maintainable code, not just coding, but creating such code which is maintainable and it is scalable in terms of future changes as per the business rule. So these principles basically help us to create clean code, flexible and efficient code. And the previous video, if you can check the previous video, we discussed about the single responsibility principle, which stands for a single responsibility or SRP. In the next principle we'll talk about is open close principle. This one is a quite simpler one. It discusses more on the object oriented programming principles such as inheritance. It's mostly revolving around the inheritance functionality of our of OPS concepts. Now O stands for open close principle or OCP. Now what does this principle supports and what does it encourage us to do? It encourages us to design classes in a way that they are open for extension but they are closed for modification, which basically means is that once a class is defined, the certain aspect of the class should not be modified. It is not correct if we have, uh, uh, let's say, an employee class in our Java object which has certain properties like its first name and the last name, and this property shall never be modified. So, in order to make this modified, uh, to make this not modifiable, certain design principle is followed wherein certain basic properties are clubbed into a different class, which is then extended via inheritance into our main class. So certain base class which are created, this base classes or a base code is not modifiable because it's not correct to modify such. As in order to avoid modification of such class, we mark those property as protected and define it into a separate abstract class or a simple class, and then extend it via inheritance property in our main higher level class, where we then extend it with different new properties. Now, by applying the OCP, we can add new features or functionality without altering existing code. Let's suppose we have a base employee class, which has base features like its first name and last name. Let's suppose that there is a business requirement in which there is a requirement we need to add in a middle name also. So that can be extended into our higher level class, which already extends the basic employee functionality like the first name and the last name. And such same principle can be applied in many other business entities or business objects like students or and one of the hands-on experience that we will be practical coding we'll be doing is we'll do it in this video. So basically OCP stands for open close principle. So let's go ahead and do a hands-on on this OCP principle and understand it more clearly. So first I'll open up the IDE and create a new package. We'll name this as com.single.ocp, just an OCP, and let me rename this to the previous one that we talked about was single responsibility. We'll rename it to SRP, single responsibility principle. And in the OCP, let's just delete the single is not required. OCP. OCP, I have certain set of codes. Bear with me. Copy this. So let's suppose we have a phone telecom network providing company. So in this, we will consider an example where they provide internet services to our subscribers. So, and our subscribers can be of different users. Like one can be a phone subscriber. So the telecom company needs to know what all are the phone subscribers, and then it can calculate the bill based on its usage. Usage here in the phone subscriber that we have four properties. a subscriber ID, address, phone number, and a base rate, and a calculate bill method where it calculates the total charge or the total amount what is to be payable by the subscriber based on its usage and based on the base rate. So, and in a phone company, there can be multiple products, and multiple products can be having a multiple subscriber. Here, we even can have a phone subscriber which can have its own calculate billing logic, when as an ISP subscriber, and then there is a internet session history. Internet session history will register the session. Then there is a call history. Fine. So we will, if you see in the ISP subscriber, there are certain properties and certain phone subscriber, certain properties which are very basic or base in terms of its value. So what we will do here is we will move all this information like a subscriber ID, address, phone number, and base rate, subscriber ID, address, phone number, and base rate into a separate class where that class will be marked as an unmodifiable class. So let's for this take it as non-modifiable class means it is not open for modification, not open for modification. Okay, and we'll mark this an abstract class. Let's generate the getter setter from the generator method, generate getters and setters, select all, generate, and let's create an abstract class uh, to calculate the bill, and an abstract method to calculate the bill. Return type will be double, calculate bill, because each subscriber will need to generate a bill. So this will be our base subscriber class, or you can see a base class, abstract class in this case, which will be non-modifiable in terms of future changes. So each subscriber now should extend to the information. So let's extend our ISP subscriber to the subscriber abstract class that we just created, and mark this one as override. So in this way, we'll make our base code non-modifiable by extending it via inheritance property. Let's suppose there is an ISP subscriber and there is a phone subscriber. And suppose there is a void subscriber. There is a fiber subscriber. So that subscriber should have a basic subscriber ID, address, phone number, and base rate information. And that can be extended via the subscriber abstract class, which is provided under this class. And let's do anything. Let's provide this as protected everywhere. So there is no need to use setters and getters method. And then we need to refactor more code because we may want to make our subscriber, the concrete subscriber classes, which is IS subscriber class, open to extension, meaning certain properties, like in the case of ISP, there is a free usage which is provided, certain functionality is provided, which is a part of an extension, so that can be extended under this class. But the base information, which is under subscriber, never gets modified. Thus, we code it in such a way that this is part of a separate class, which is then extended and not modifiable. So this is the basic principle: open for extension, closed for modification. It's a very basic and simple concept. So let's refactor the phone subscriber class. Let's extend this information and we'll subscribe this information. And this information now is coming from our abstract class. So we will remove that part of code. Then we will remove all the getters and setters which we are directly populating from the subscriber abstract class, and the method itself is coming from the abstract. So we'll add the override annotation, and it should be overridden. because it overrides the method that we provide in the abstract class. So this is how we can follow the principle of open and close information and make certain piece of code as a base code and make it unavoidable. This concept is highly useful in the data-driven architect, data-driven development process, wherein we create a business object and entity class based on the base entity class, which are certain properties and certain methods which are non-modifiable, and certain projects which are abstract. So that kind of data-driven development (DDD) that we say can be is highly based on this principle of open and close, principle of under the solid design principle that we are discussing right now. So this is the second one which we discussed. So advantage is that by applying OCP, we can add new features or functionalities without altering existing code. Why is this useful? Because this promotes reusability, meaning any other the developer's task is reduced. Let's suppose in this we have a VoIP subscriber coming in. So we will add in a new class, let's say VoIP subscriber, and the VoIP subscriber is extending to the subscriber class. So the coding task also is reduced and makes it highly reusable in terms of implement this method. And let's say it has its own method and there it's extending to certain other properties like private string void provides certain discount, let's suppose discount on the final price. So that can be discount spelling discount. This information can be utilized over here under the overridden method for design. So this is how this principle becomes helpful in terms of designing the software from the scratch. This promotes reusability and minimizes the impact of change on existing systems. So thank you for watching till now. We are reached to the second principle, which is completed this now. Third one is core principle. Then we have interface segregation principle and dependency inversion principle. So see you in the next video where we'll discuss the third principle. Thank you for watching. Have a nice day.